Welcome everybody to MusicLab 5 Lockdown Rave. MusicLab is a project in which we aim to study the performance and perception of music in the real world. MusicLab is live music with live research. And we combine this with an element of science communication and data jockeying, which is analysis of data collecting during the performance. MusicLab is a joint project by RITMO Center for Interdisciplinary Studies in Rhythm, Time and Motion and the University Library in Oslo. Today, if you choose to participate, you will listen to two Algorave performers, respond to some survey questions, and your movement will be measured. The mandate of MusicLab is to engage the audience and participants in the research process and to draw away the curtain on the mysteries of music science. If you do join as a guinea pig, you will be serving open science. Isn't that a glorious cause? At MusicLab, we believe that the joy of music is intrinsic to most or all human beings. So by participating, you will help us learn not only about our experience of music, but also about what it is and what it means to be human. We invite you to download the MusicLab application, available on the Play Store and Apple Store, through the link in the description. It's important for the integrity of the research that you listen carefully and follow along with these instructions. If you have any questions or problems with the app, please write them in the comments of the video, and one of our moderators will assist you. Since we aim to record your body motion, we would like you to place your phone somewhere on your upper body, screen facing out, for the duration of the 2 half-hour performances. If you have access to a shirt with a chest pocket, it would also be helpful for you to put it on now. Alternatively, you could place your phone in any other clothing that is on your upper body. I'm going to do it like this. As a last resort, you may place it in your pants pocket. Since this is a rave, we also encourage you to stand, if you can, to watch the concert and dance if you feel the desire to do so. It's also important that you do not close and reopen the application during the concert, because you are automatically given a unique user identifier that links your survey responses to your motion data. Responses are anonymous and you can withdraw your consent at any time. If you are worried about your battery life, you could put your phone on airplane mode, but then make sure to turn on location and Wi-Fi. Once you have downloaded the app, please allow the app to access your device's location. Please navigate to the Data tab. Make sure you have 3 green check marks next to accelerometer, gyroscope, and geolocation. If you have any red crosses, try restarting the application. Then navigate to the Pre-form tab on the bottom left. The beginning of the form shows the consent form to participate in research. You must be over the age of 18 to participate, but those under the age of 18 may still enjoy the live-streamed rave. Below the consent form, there's a survey that collects information about your personal characteristics and prior experiences with music. Please press Submit at the bottom of the page once you have finished the survey. If you are using the iPhone application, please make sure to answer every question before you press Submit, because the iPhone application does not submit without every answer, and it can only be submitted once. You should receive a notification that says, "Form submitted successfully." This should take approximately 10 minutes. start recording, press Start Capture. You will see numbers updating that show general information, your acceleration, rotation, and geolocation. The Android application can be pushed to the background by pressing the Move to Background button. The iPhone application, unfortunately, cannot be moved to the background and the screen must stay on, because in the Apple version, the application stops recording and does not send data if you turn the screen off. To send the data and stop recording, you must press Stop. You should receive a pop-up alert, data sent successfully. So, we would like to record some baseline measures from your phone. We will do 3 different measures. First, a 10-second baseline of your phone lying still on a flat surface. Please press Start Capture and place your phone on a flat surface. We will wait for approximately 10 seconds. So you can do that now. Start Capture. Okay. So now you can please press Stop. And you should receive an alert that says data sent successfully. If you did not receive the message data sent successfully, please comment on this video and one of our moderators will try to assist you. Now it's time for the 10-second still body test. Now we will measure your motion while you stay still for 10 seconds. So please press Start Capture and place your phone on your upper body where you will be wearing it during the performance. And after you do that, then you will wait for 10 seconds. So I'm going to press Start Capture. Then I place it on my upper body. Then I stand still for 10 seconds. Thank you. And now you can press Stop. Again, if you did not receive the message data sent successfully, please comment on this video and one of our moderators will try to assist you. To indicate when you first hear the music, we would like you to press Start Capture while your phone is on a flat surface. As soon as you hear the first sound, please shake your phone twice and place it on your body, like this. Okay. So now we would like to introduce our first performer. His name is Renick Bell. Renick Bell is one of the leading figures in the Algorave movement. Mixmag magazine has called him one of Algorave scene's most flabbergasting producers, and Resident Advisor calls him Algorave Kingpin, and writes that watching him make his music is just as fun as dancing to it. Renick Bell improvises bass-heavy, algorithmically generated music full of percussion and noise by live coding with open-source software, including software he has written called Conductive. Each performance is new and unique, unheard before the event, even by Renick Bell, with his live programming activity projected for the audience to see. In 2019, he was selected by Aphex Twin for the latter's first ever curated event for the Warehouse Project in Manchester, UK, where he headlined the Archive Room stage. In 2018, he released an album called Wary on 2018 Grammy-nominated producer Rabbit's Halcyon's Deal label, and another called Turning Points on Seagrave Records, which was a critical success, including being ranked 19 out of the 50 best albums of 2019 by Fact magazine. He has releases on Lee Gamble's UIQ label, Berlin-based Conditional Records, and Saplings Records, among others. His music practice corresponds with a research practice of writing software and writing research papers on live coding, electronic music, and art, as well as teaching in university and other contexts. Based in Tokyo since 2006, Bell has lived in Asia since 2001. He's originally from West Texas. So there will be a slight delay between when I say goodbye and Renick says hello, but stay tuned. He will be here momentarily. Now please place your phone on a flat surface. Press Start Capture to start a motion recording. And get ready to shake your phone and place it on your upper body when you hear Renick's first sounds. Remember to stand for the performance if you can. Most of all, remember to have a good time, and I will see you in a half hour. Now, here is Bell. Wow, I can practically hear the applause from all over the world here in Sakala, Finland. To the audience at home, please navigate to the MusicLab application on your phones and press stop. Wait until you receive a message that says data sent successfully. This may take a few moments. Now navigate to the Post Form tab and spend 3 minutes filling out the top half of the form with questions relating to Renick Bell's performance. There will be text thanking you for filling out and a headline that says Performance to Khoparzi. Wait until Khoparzi's performance before answering the questions related to his performance. Then you may submit the full form. I will give you a few minutes to fill out the first half of the form. And I will also be filling out mine. Okay, so thank you so much for filling out the form. If you think you may need to leave before the end of the next performance, but would like to submit your answers, the iPhone version needs responses in all of the questions to be submitted. Therefore, if you need to leave, please answer 1 for every question in Khoparzi's section and answer no to the question, did you attend Khoparzi's performance? And then press submit. For those iPhone users just tuning in who are joining us for Khoparzi, you can join in on the experiment by downloading the MusicLab App in the description and following along. You can fill out the pre-form after the experiment, and when you fill out the post form, you can answer no to the question, did you attend Renick's performance? And 1 for all the questions relating to Renick. And then you can respond just to Khoparzi's question in the second half of the survey. So, our next performer is coming all the way from India. Khoparzi is a multidisciplinary creative technologist who maintains a practice along film, video, music, and web technologies. Having always tried to run away from being put in a box, he has in turns been a consumer, critic, and maker of tools that allow him and others to make experiences that makes us think, play, and inform. He is interested in using technology itself as a medium that can be molded into various forms to tell stories and build experiences. To this end, he collaborates with various artists and technicians to tackle creative, interactive, and technical challenges and explore various permutations and extensions of art. As a musician and sound artist, he has performed experimental electronic music at venues and events like the Indian Electronica Festival, 6-foot oscillator in a 4-foot room, Float Sam with Mukul Deora and Pier Paolo Alessandrello, and other collaborator performances with artists like Cargo Pluggy and Sadanmo from the Third Thought Entertainment roster. In 2018, filmmaker and visualist Danya Pilo and Abhinay co-instigated Algorave India, a collective of artists, musicians, and visualists intent on promoting programming as performance art through algoraves. As an extension of this, he has performed with live coding platforms Tidal Cycles and Hydra at Fat Finger Mayhem, Algorave Sheffield, International Conference of Live Coding in Madrid, Distributed Culture Conference in Argentina and the UK, Algorithmic Remote Algorave in Turin, Italy, and organized and curated multiple independent algoraves in Delhi, Mumbai, Pune, and Bangalore. Since 2018, Abhinay has been collaborating with artists from all over the world with network music performances with the Intercontinental Live Coding Ensemble, Supercontinent, and with remote ensemble Algomesh, which is a collaboration between PsyLC Argentina and Algorave India. Now, recall that there will be a slight delay between when I say goodbye and Abhinay says hello, but stay tuned, he will be here momentarily. Now please place your phone on a flat surface and navigate to the Data tab. Press Start Capture to start the motion recording and get ready to shake your phone and place it on your upper body when you hear Khoparzi's first sounds. Remember to stand, if you can, for the performance. Most of all, remember to have a good time, and I will see you in a half hour. amazing. Thank you so much for that incredible performance, Khoparzi. To the audience at home, please navigate to the MusicLab application on your phones and press stop. Wait until you receive a message that says data sent successfully. This may take a few moments. Now navigate to the Post Form tab and spend 3 minutes filling out the second half of the form with questions relating to Khoparzi's performance. You must respond to all questions before submitting the form, so please make sure you answered all questions before pressing submit. Please make sure you press the submit button at the bottom. We would now like to introduce our panelists. We have invited performers Khoparzi and Renick Bell to discuss their experience with music researchers Qichao, Jonna Vuoskoski, and project leader Dana Swarbrick will moderate the discussion and take questions from the audience.
Hello, everyone, and thank you so much to Renick and Abene. That was absolutely amazing. I've just invited all of our panelists to please enter our Zoom conference call, and I'm so excited to dig into some questions, not only from the audience, but also some that I've prepared. Again, my name is Dana Swarbrick, and I'm a doctoral researcher here at the University of Oslo, and I work with Dr. Jonna Vuoskoski, who is my supervisor, and together we're trying to understand how it is that live music can change things about our the interaction with others, as well as within our own bodies. And I'm going to pass around the mic to have everyone introduce themselves as well. Renick, could you give us your introduction?
Yeah, sure. My name is Renick Bell, and I live in Tokyo, though I grew up in Texas, and I've been live coding for many years now.
Perfect. Thank you so much. And Qichao, could you introduce yourself?
Hi, my name is Qichao. I'm currently a PhD student in the RITMO Center. I'm also a live coder, and I have developed my live coding language and environment called Quiver series. And currently, I'm doing research on how the musical interactions in this language and environment can influence the live coding performance. Thank you.
Jonna, could you also introduce yourself?
Hi, everyone. My name is Jonna Vuoskoski. I'm an associate professor at the University of Oslo. I work at the RITMO Center as well, and my area of research is the psychology of music and music cognition.
And Abene, thank you so much for coming in. I know that was a quick turnaround. Can you also introduce yourself for the audience?
Hi, I'm Renick Khoparzi, and I am a live coder, musician, filmmaker. I run something called Algorave India, which is organization. It's a artist collective organization, and basically we just try to put on live coding gigs all over the country. Yeah.
Brilliant. That's awesome. Yeah, I really loved that performance, and Solveig and I actually were dancing along in this Zoom meeting. I'm going to start us off with one question. So I wanted to actually ask Jonna first, why is it that this music makes us move?
Well, we actually know from brain research that when we're listening to music that has a beat, has a clear beat, that the areas in the brain that are activated are actually those that are responsible for movement or motor action and movement planning. So it seems that somehow we understand rhythm through movement or body movement. And it's also thought that it's actually helping us to make sense of rhythm better when we're moving along with it. And it seems to be a pleasurable experience for most people as well.
Amazing. Thank you so much, Jonna, for that. And Qichao, since you study live coding, can you comment on how does live coding actually differ from performing on a real instrument?
Well, I think first we need to define what kind of real instrument we are comparing live coding with. I would say, for example, synthesizer can be very different from a guitar, right? So if we compare live coding with playing a synthesizer, I would say in live coding, we make a lot of discrete decisions because this kind of music is often updated based on the unit of bar. So sometimes when I select a parameter, and if I want to change it, I have to wait till the beginning of next bar. But on a synthesizer, we can just tune a knob and find the sweet spots we like. And if we compare live coding with playing a guitar, I would say when I play the guitar, I think less. But in live coding performance, I tend to think more, and especially the computer programming part. I'm probably, I may be thinking the error handling and how I should organize the code. Yeah.
That's really cool. And I wonder, Abene and Renick, I never asked you this, but do either of you actually play an instrument other than the computer? Abene,
yeah,
can
sure.
you tell me what
Okay,
instrument
Abene.
you play? Oh, sorry, Renick.
That's all right.
So I play drums and percussion, I would say. That's kind of what my main focus has been for the past few years. I've been sort of playing with electronic instruments as well, but it's kind of hard to get hold of them in India. They're very expensive, and a few friends have started making a few. So now I'm sort of outgrowing the staying in the box and mixing in the box sort of thing. I do have some equipment, but it's been collected through years, and by the time you become proficient in it, it becomes outdated. So kind of try to stay within the. That's a great thing about like actual real instruments, that you can just keep them for years and years. Like my drum kit, one of them is like 30 years old, and
Wow.
still sounds better now.
That's awesome. And how do you feel that your mental state differs between live coding and playing the drums, for example?
So the way I look at live coding is more as a musician in that way that a lot of the keystrokes and little patterns are literally just practice putting them down within a certain amount of time. So it's almost like an instrument for me. I do agree with the point where you're thinking more about it, but there are some things you kind of develop muscle memory on, which is what I was having a bit of a hard time today because I was using a different keyboard than what I usually use. Because we wanted to stay standing up playing, and usually at real gigs I'm playing off my laptop, which is on a similar stand, but it's a different keyboard layout. So it's almost like your instrument has changed a little bit.
Yeah, that's super fascinating. Wow. Okay. And Renick, can you tell us about what real instrument
Yeah.
you play and how that compares to the mental state you have when you live code?
Yeah, I've played a lot of instruments since I was a kid, but these days I mostly just live code other than playing maybe a modular synthesizer. And I think what Qichao said is really right about the difference in thinking about time. So when I used to play drums or a guitar, I have to think continuously, and I have to think about my actions, my physical actions in every moment. Whereas when I'm live coding, I'm thinking more about the structure of my performance, the form. And so the decisions that I make are more at a distance of, at least as far as the audience will hear, are more at a distance of separated by maybe 10 seconds or 20 seconds or even 30 seconds. So there's a very big difference in how I engage with time.
That's really cool. That actually takes me to my next question for you, both of you, Abene and Renick. How did this experience of live streaming without a real audience with you compare to what it feels like to both, I guess, perform with your real instrument to a live audience and also to live code with a live audience?
Abene, go
Renick,
ahead.
you want to take this one first?
Yes, go for it,
You
Abene, sorry.
yeah.
Abene, you go ahead.
Okay, all right. So for me, I have to keep checking like comments and like see what people are saying, because you do kind of need feedback of, especially with music that you want people to dance on, or maybe there's parts where you think about the music, but there's also the physicality of it, if people are feeling it or not. So that's something you do kind of miss in a live streaming gig, but it does give me a lot more leeway in terms of the amount of equipment I can take to the gig, because I have my nice desktop and two monitors, and I can keep checking on multiple things, all of that, which is very hard to get on a gig.
Yeah, no, it's I've experienced that today, so I totally understand that. And Renick, how did you feel about today, and how it differs from a real concert?
Yeah, the big difference is the sound system. So I'm in my office right now, and even though I have a subwoofer here, I don't play with the subwoofer until after midnight when I'm sure that the other tenants are gone. So today I'm playing with just headphones, and I couldn't feel the sub bass so much. And so that definitely affects how I feel the music, and probably affects how I play as well.
Whoa, cool. That's a
Yeah.
super embodied experience you're talking about there.
Right. But usually at a gig though, there's a very big sub bass, and that really has a big impact on the perception of a rhythm or groove, I think.
Yeah, absolutely. And I feel like our listeners at home are also limited in that respect because we're all basically using headphones today. And unless if anyone out there has a lovely sound system they're listening on, which is I'm jealous and envious of you, and we'll have to try to watch it again with that better sound system. But that also kind of brings me to another question, which is for Jonna and Qichao. When you were watching the performance today, did any questions, research questions, pop into your head? And if any did, how would you answer those questions? Jonna, you can go first.
Yeah, well, one question that popped into my mind has to do with, so I'm of course approaching things always from the kind of a music cognition point of view or perspective. So because there were definitely differences between the two sets in terms of how I don't like the word to use the word predictable, but maybe like how well people could anticipate the beat, for example, or how complex the beat was, or how much it was changing. And also within the sets there were differences. And we know that there's this relationship between how much people want to move and the complexity of the rhythm or the beat. And it's not like a straightforward relationship, but it's kind of an inverted U curve where there's like a sweet spot of optimal complexity, so it's not too complex, not too simple, which makes people move the most. And now having hopefully a lot of interesting data from the MusicLab app of people's body movement, that could be one thing we could look at, like how, if there's a relationship between the complexity of the beat and how much people move, for example.
Yeah, no, I'm super excited to dig into this data. Qichao, what was your experience like, and did you have any questions that popped into your head?
Sorry, I just muted myself. I think I'm approaching this question from a music technology perspective. So what I'm thinking is that since we are having this form of performance, and as Renick just said, it's very different from a real physical rave. So I'm thinking, how can we get the audience more involved in this performance? And actually, this is part of my research, because the live coding I design is based on the web browser. So you basically do live coding in a browser, and all the audience should go to that same website. So I'm trying to experiment on different approaches to get the audience involved in this live coding performance more. Yeah.
That's awesome, Qichao. Yeah, and yeah, I feel like actually your research, even though you say it is from a completely different angle, it is bridging the same question, which is on connectedness. How can we make people feel connected through music? So that's really, really cool. Turning again back to Abene and Renick and your experience of performing today, I have a brilliant colleague who's just been hired in Denmark, Simon Hofting, who researches the mental states of experts while they perform. And his research suggests that they can experience anything from being completely absorbed in what they're experiencing to having out-of-body experiences to mind-wandering and thinking about the groceries that they're going to buy later. And so I was wondering, today in particular, where was your mind at in this live stream performance? Renick, do you want to start this time? Sorry.
Okay, that's all right. So one of the things I often say is that I always feel personally I don't have enough time to practice. So for me, every performance is a kind of practice, and I set up some kind of goals that I want to practice while I'm performing. So that's one of the things that I'm thinking about. And I'd say on that spectrum that I fall in the completely absorbed side. So, and one of the goals for my personal research is that I'm trying to automate my system so that I get more time to be a little less completely involved, so that I can step back and listen and personally evaluate the music at a little bit more distance and maybe perform in a kind of different way. So I'm always thinking about the kinds of things that I'm going to practice in my performance, and I'm thinking about things like transitions and how to go from one rhythm pattern to another, especially when I know that the rhythm patterns are very complex. So that's the kind of things that I'm thinking about very hard as I'm playing.
Yeah, wow. Okay, so you're completely like always on thinking. Yeah, I think that Qichao made that good example that there's definitely differences what you have to do with a real instrument and live coding. Abene, what was your experience like today?
So with the practice thing, I kind of developed these shortcuts for myself, which do a lot of the work for me. I think it's a simpler version of what Renick does, where I'm thinking more in terms of, so my specific version of title cycles, I've sort of customized it to basically the styles and rhythms I would be probably using. So all the transition bits and all that, so there will be like five different footwork patterns, and I can just shuffle between. So there's less of thinking about how to implement that algorithm, rather more about, okay, what do I want coming in at this point? Or it's almost like a very DJ-like thing where, okay, which track I'm going to throw in now.
Cool. And I like, actually, that's a perfect transition for the next segment, because for those of you that don't know, Abene was coding on tidal cycles, and Renick, you were coding with your own program called Conductive. Is that correct?
Right.
And it looks like so you both had automated several components of the performance, and so that you were more able to actually do the things that you really enjoy in performing. And our next guest, Çağrı, who's actually a researcher, and I were discussing how we can do something similar to live coding performing, but in the data analysis. And so I'm actually going to invite Çağrı in now to join us, and we're going to begin a segment called Data Jockeying, which Solveig will tell you more about. But thank you so much, panelists, for joining me, and
Well, thanks for
I look
having
forward
us.
to talking more.
Thanks for having us. Yeah.
Yeah.
Thank you.
Thank you, and back to Solveig.
Okay,
Solveig,
so
take over.
yes, so now we have reached the final chapter of this music lab, which is the data jockeying part. And data jockeying is live analysis of the behavioral or emotion data that's just been collected from you, the participants. It gives us insight into your experience of the music and what happened to your body as you were listening and raving to the music. There's still a lot of analysis to be done by the researchers, but this is a preliminary interpretation of the data. Çağrı Erdem, who is also a music researcher, will be playing with the data and explaining its significance. So welcome, Çağrı.
Okay, so the first thing I want to do is to define a path to where I stored the data, and so this is gonna be my path. So it's MusicLab, and today's date is okay, and then I want to define yeah. Who is for, and so, well, in the short time I tried to look for the available data, and so I kind of choose the 13 most looking most clean. So there are more, of course. Okay, so I'm gonna just reuse some functions that I previously write, and this function will help me to find the CSV file in my directory. So so it's gonna be path, and the data I want to particularly take the data number 2, but we don't have that. Why we don't have it? Let me check.
Çağrı, can you actually make your font bigger? Can you zoom in a little bit more?
Oh yeah, sure. Like this?
Even wider, so it fits the full browser, like width.
Something like this, maybe.
Brilliant. That's awesome. Thank you so much.
Okay. So why it doesn't work? Oh, so that's why it doesn't work. Oh. Let me take it from here again. Oops. Why did I do something wrong? MusicLab. Oh, interesting. Ah, yeah. Let some typos will yeah make your life really. Okay, so now I just want to store the CSV files in, and so it's gonna be one, and I also want to store it for my geo data where this is gonna be, yeah, and then I want to see how my raw data looks like. Okay. Let's see, it's gonna be motion, oops, motion, this is how our data looks like. Okay, so but what does this data mean for us? So there's X, Y, Z, and alpha, beta, gamma. So that's why I want to also show what. But I need to find the right. Yes, this one. I want to show this. So okay, so this is basically how how data looks like. So Y is more like the vertical, and Z is more like frontal, and X is more like lateral, so side to side. Okay, so from there we can let's just plot the accelerometer data in the first place and see what we got here. For this one, I want to plot as 23. So, so this is how our data looks like, and maybe okay. So let's see how our other data looks like then. Maybe we can see something a little bit more interesting. Yeah, here, yeah, it looks a little bit more interesting here. Okay, so the next thing I want to do is we ask participant to stand still, like put the phone on the surface and then shake the phone in the beginning of music. So what I want to do is to like cut the first off, and yeah. So in order to do that, I want to have this. So I want to see if it's so we can. But before that, let me just. But before that, let me just do something else, which is so, oops. Okay, so it will make our job easier. So then we can say, okay, so it's this maybe. Yes, so we can cut it somewhere around here. Of course, like in a thorough analysis, like we have to do it a little bit more sophisticated in a sophisticated way. But for now, I think it will be enough for us. Okay, so I want to then just find the right index point of this this point, the index of it. So in order to do that, I want to take our name of it. Whoops, because so this is our point where we will cut it. So okay, so what we're gonna do is so I want to have it from this point, and I don't want to work on the entire half an hour. So maybe we can use something like I don't know. Let's see. It's gonna give us. Okay, so then let's see this raw version again. So what we have here. So okay, so this is what we're gonna deal with. All right. So then let's see what's the duration of the file we're dealing with. Okay, so to do that, I need to motion values. So I want to just do you remember, like, we have this time array here? So I want to just subtract the last one first from the last one, so that we will see what we have. What we have there. Okay, and then I want to just a minute. Okay, then I want to okay, so we're dealing here with something like 5.7 minutes, and then the next thing we need to do is we need to find the frequency of our motion. So in order to do that, I just want to take the mean of the rate of change of our time axis, and but I don't want to deal with lots of decimal points, so I will take it maybe 3, and of course I need to multiply the 1000, so we will find the cycles per second. And so apparently our sample rate is something around 60. Okay, now we can define a new time data for our new segment of data. Okay. Okay, so this is our new time. All right. So now since our raw data looks a little bit messy, I want to do some processing here. And for processing, I will rely on some functions that I wrote previously. And I'm gonna use filters from the SciPy library. So what I'm gonna do, I just want to first use my I want to define my columns, and then I want to store everything in a list so that I can easily bandpass filter. So this is my data, and I want to filter it. This is going to be a bandpass filter. I want to filter it from 1 Hertz to 10 Hertz, and the sample rate is my frequency, and I want to use the 4th order filter. These decisions, at least for me, are mostly empirical because I decided on using the fourth order filter after trying the different versions. Okay, so in the next step, I want to normalize my data, which is quite important for many reasons. And this is the normalization function that I wrote for the time, for the sake of time. So I want to again store everything in here. So but I would usually you normalize between 0 and 1, but in this case I want to normalize between -1 and 1. So that's why like I did this and oops, norm. So if everything's fine, yeah, everything looks fine. Okay, so we can now finally start plot some nicer looking accelerometer axes. Okay, so I want 3 rows, but just 1 column, and let's put something. Okay, so I want to also define my labels in the beginning, so that's going to be easier. Also some colors to make it look a bit nicer. Okay, so for axis number in range 3, since we have 3 axes, so I want to plot first of all time, of course, and then our axes, and I want to use also color, and I want to add some legend there. Put in lower right. Let's see how it goes. Okay, so this is how our filtered data looks like. But you know, just to make it a little bit more understandable, I'll just add these here so that we can see it better. Okay, so all right, let's move on. And in the next, I want to extract some features from this data because still it's still a little bit obscure for me. So I want to extract one of the most well-known feature, which is called quantity of motion. So, and in order to do that, I will just use my previously written function. And so we have time, we have norm. So this is our x-axis. Oops, no, of course not. This is our x-axis, this is our y-axis, and this is our, so if everything looks fine, all right. So, but I want to normalize it even further, because, yeah. Okay, so, but even this is gonna look a little bit messy. So I want to use another filter from SciPy library and filter the quantity of motion. So it's going to be a little bit more filtering here. So this is why I'm going to take this and I'm going to use this and I'm going to define my window size. Let's go with this and the order of it. So, okay, so then I can now normalize this filtered one and store it in another. Okay, so now it's going to make more sense when I bring my plotting function here. Just, you know, I did it beforehand just to not lose so much time. So when I oops, when I plot these, so this is why I did some further filtering so that we can see that this 5-something minute segment, the person, so this is the first shaking part, and so this is how it looks like here. Okay, so I will move on because I also want to show you how motion looks in a more spatial, the acceleration looks like in a more spatial way. So I will just steal it from here. Okay, now I want just one row, but I want 3 rows. Okay, so I want to first plot my, okay, I first want to plot y-axis against z-axis. Okay, and I'm gonna color it as red, and I'm gonna label it as y against z. Okay, so then I want to plot this time x-axis against z-axis. So I want to do that. Gonna be like this, and finally, I want to plot x-axis, but this time against the vertical y-axis. So it's gonna be side to side to vertical. Okay, so and I also want to write like a little for loop for my legend. Let's put it, oops. Okay, so let's see how, oops. So this is how this looks like. So in this planar plot, so we can see how vertical against frontal in the first one, and then how side to side against frontal, and in the end, in the third one, how vertical motion draws this shape against the side by side against vertical motion. Okay, so let's move on since I don't have so much time. Now I want to do some, I want to detect some motion peaks, and in order to do that, I'm gonna use another library called Sensor Motion. This is a really cool library, and I'm gonna use another function that I previously wrote. So peak values, peak times, values. Okay, so time is our time, and for signal, I'm gonna use this average function where I will put my filtered list of phi axes, and as peak type, I'm gonna choose value. And as the minimum value, which is the threshold for detecting the peaks, I'm gonna choose 0.6 right now, but we can decide on which one we want later when we plot it. And as the minimum distance, I want to use half of my frequency, so which is like half of a second cycle. And I want to see what's going on. So this is a very nice of this library, so you can just plot it on the fly. And so apparently maybe I should Yeah, I see. So yeah, this is where, yeah, in order to find the peaks, yeah. So maybe a little bit, yeah. Okay. So in the next one, I want to look into the periodicity of. So we're gonna look into the spectrum of what's going on. We were mostly in the temporal domain so far, in the time domain so far, but now I want to go into more spectral domain. So that's why I'm using another SciPy library. I don't know what we would do without SciPy. So it's really nice. And okay, so again, I will do a list for my sample frequencies and power density of my axes. So signal, field norm, and I will use my sample frequency, and I want to use panning window, which is the safest window when you're exploring things, and I want to use scaling as spectrum, and then I want to append everything in my list as a tuple. So if there's no typo at all, it should be fine. Okay, so I will just now use some plot, the function that I also wrote previously. So I will just plot these and see what's going on there. Okay, so from here, we can say that the strongest seasonality, so strongest frequency of motion looks like it's below 5 Hertz. So so if we look at it in this non-log scale, so it will be more visible. But still, we don't know which are those frequencies. So for this ambiguity, I have another function which will provide us the top 3 frequency of these axes. So I just want to copy paste this, and I want to have that, and this is the sample frequency, and then this is the, okay, so this is X. So I will do it for oops, and voila, and this. So from here we can see that, okay, so for x-axis we can see that the strongest seasonality is around 7 BPM. When you'll be looking at y, it's around 300 BPM. So I mean, this we can think it in a half-time way. So we can assume that this is more like 150, because like it won't be. So I don't know who can dance at 300 BPM. Okay, so in the next, like I don't have so much time, so I want to get in the audio just a little bit. So let me write it here, and I want to import Librosa, which is another very useful library for us. Notepad, join. So by the way, this data that I've been exploring was from the first set, which was Renick set. So that's why, like, I'm gonna import Renick's recording, and I want to cut it based on the duration of our of our data, and then I also want to look if everything works fine with our sound and rate. And okay, so let's see. Very nice. Okay, so here another function that I previously write. This function first decompose the audio signal into percussive and harmonic elements, and then I detect the onset strains based on the percussive elements of the audio. And also I'm gonna try to, I'm using a tempo detection algorithm based on this, this percussive, decomposed percussive part of it. So audio features, onset, tempo. This will take a little bit of time, and while it's doing this, I just want to plot. I mean, not everything, but most things we had so far, so that we can understand it better. Okay, so now I want to have one column but 3 rows. Okay, and I want to first plot. So in the first one, I want to put my time and the onset strains of the audio, and then in the second, I want to plot the peak times and peak. Let me just normalize the peak values here. Peak values. So I want to peak values here, and finally I want to plot the quantity of motion so that we can see everything nicely. Okay, so if this is fine, so if everything's fine, we're gonna see. Okay, just let me put here some colors. Let me make it blue this time, and green. Okay, so yeah, well, we need to just you know, do some more scalings to make it more sense for us. But well, just by looking at this, just by looking at this, I can say that there's some alignment, but of course it requires some more detailed analysis on it. So, and when we look at it, so the first 5-6 minutes, it looks like the tracked tempo is around 105. So if we go here and I want to just check the major frequencies, so the data that I'm just looking for, so it's, yeah, well, it doesn't look like it's aligned that perfectly, but yeah. So, but that's one way of approaching it. So we can just calculate the periodicity in the frequency domain of motion, and then look how it aligns. But of course, we need to make it by windows, you know, choosing the particular parts and everything. And I know my time is up, but finally, I just want to just look this data, this particular data that I was looking at, coming from which place in the, because I don't know if this gonna happen? Okay. So yeah. So now I prepared another kind of a big function. I hope it will work. Oops. So we're using some libraries for fetching data from a map API. So if everything works, then yeah, Qichao, latitude values. So oh no, it's gonna be longitude values. So I'm gonna make it this data is from Oslo. Okay, so that was it. I'm already ahead of time. Okay, so thank you, everyone.
Okay, thank you, Çağrı. What was the most interesting thing that you could see from the data so far in this very short analysis?
Well, what I can say about in this short time before this data jockeying, I was looking at different data, so how they look, and I think the most interesting part is to see how much the periodicity of motion get closer to the tempo, and tempo changes in the music. I think this is super interesting in terms of entrainment, first of all, and I think it is a very big interest of Dana and Jonna, and it's a very interesting topic. So I would really like to explore that aspect more. So briefly, I would say I would like to go towards more comparing the both kinds of data in frequency domain. So that's very interesting to me.
And not to like yeah, bother you too much with it, but could you just like in just a few words also explain it for the people among us who are not researchers?
Yeah,
or
of course. So what? Of course. So what I, well, yeah, that's true. Okay. So what I mean is, so the way we move, the tempo of how we move, it somehow aligns with the music, right? Like we node our head, we node our body, you know, with the beat, and so there's lots of similarities in this. So I think that's extremely interesting to see which part of our body aligns with the beat, because we don't move in the same way all the time, right? So we move side by side, we move vertically, and we move in the three-dimensional space. So it's really interesting to see, you know, that alignment with the sound.
Awesome. Yeah. Well, thank you so much for this analysis. I know it, yeah, it takes somebody really with guts to be able to code on the go like this. It's very interesting, and thank you for making it understandable to me and other people who don't know a lot of coding. So yeah. And I just want to conclude this event. Thank you all for joining us here today. And thank you to the ones who participated by giving off their data as well. That's really, really awesome. We are so thankful. And thanks for everybody who took part in this. Big thanks to the performers Renick Bell and Khoparzi for their awesome sets. And thank you to the panelists, Qichao and Jonna Vuoskoski, and to Dana Swarbrick, who has been holding all the threads in this edition of MusicLab. Thanks again to data jockey Çağrı Erdem, and everyone involved backstage, including Kayla Burnham, Rebecca Bergström, Matthew Good, Alexander Jensenius, and many others. And last but not least, thank you to all the people again who participated as research participants. It's really, really great, and we owe you everything. Your data will greatly help in our quest for knowledge about music and humanity.